All right, thanks, Jim. Great to see so many folks here today. And I think since I'm from New England, I can very confidently and happily say that this is, in fact, the Super Bowl of security conferences. And I know Jim has invested a lot in this show, and I don't want to steal your thunder, but after lunch, Jim is going to fly in from the ceiling and introduce the afternoon. So I'm going to be talking about the software-defined perimeter, which is, get this going here. There we go. Let me go back. A key ingredient in the cloud security pie. And I think, as you may be able to guess from the title, I really like cooking. I think it's a pretty incredible process to be able to take a variety of ingredients of different types and perhaps of different quality, and with a little bit of hard work, combine them into something that's amazing, or hopefully amazing. And I think that it's an unfortunate fact that too often us on the security teams come up with something that isn't amazing. It disappoints our business customers. It disappoints our IT and security teams that are responsible for operationalizing it. And it disappoints our compliance teams that are responsible for proving that we meet our controls and report on them. But I think that with this new ingredient that I'm going to introduce today, this software-defined perimeter, or as we affectionately refer to it, SDP, it can make a difference, and it can really improve the recipe and improve the results of our security pie, so to speak. So the software-defined perimeter is, in some ways, a new network security model. In some ways, it's actually old, or as I'd like to say, well-proven. It stems from some security research that's been done and deployed in military and DoD networks. And the general approach is that it blackens the network. It hides servers from unauthorized users. And as authorized users connect to the network, then and only then are they allowed to see the services on the network that are appropriate for them. They get a secure connection in a way that's individualized for each and every user. And when done properly, it actually simplifies and improves security, and does so in a way that's dynamic so we can operate at scale and at speed that we need and want for our businesses. Now let's take a step back and take a look at some of the trends that we're all experiencing. I think that we all understand and probably have lived through this shift in IT becoming much more hybrid and much more diversified over the last, let's say, 5 to 7 years. And I want to share 3 numbers with you to demonstrate that. The first is 80%. In a recent IDC survey, enterprises indicated, 80% of enterprises said that they'll be embracing and adopting hybrid cloud architectures by the end of this year, where traditional IT resources will move from corporate data centers to cloud environments, to co-located facilities, or even off-premises to customer and partner locations. In fact, the same survey predicts that 65% of IT assets will be off-site in the same time frame. That's a huge shift. But, and of course there's always a but, there are security concerns around this. In the most recent Cloud Security Alliance survey on this, 68% of organizations indicated that they were concerned about security. Doesn't mean that they're necessarily fighting with this shift. I think many of them are embracing it for technology and economic reasons, but there are definite security concerns. You heard in Julia's presentation, she mentioned the figure 50%. Hopefully we're improving. That's still a very significant proportion of organizations that are concerned about the shift to the cloud. One of the implications of this change is that now we have a much more diverse and fractured environment. We have IT systems and security systems and business systems that span different platforms and technologies and certainly different locations. And what that means is we're trying to manage all this across a very diverse set of platforms and tools, and probably a very diverse set of teams of people responsible for managing and operating this. The implication of this is that we end up with this fractured view with no single policy model, no single view, and no single enforcement point for security across this landscape. The end result of that is complexity, and that complexity leads to business friction. It leads to difficulty on the security and compliance side, and it certainly leads to lack of visibility and vulnerabilities that our attackers are more than happy to exploit. But I'm an optimist, and let's view this not necessarily as something to be fought, but something to be embraced. And if we look at the trends that our lines of business are embracing and utilizing, there's certainly been this very significant shift from hardware-based infrastructure to software. And this goes beyond the traditional compute infrastructure to storage and network functions and security today. With this shift to software, everything has an API, and it means that we can move to an environment that's much more dynamic. And we see our lines of business really embracing this and innovating and coming up with new and exciting ways to connect their lines of business with other data sources and other organizations. And we're really moving to a much more interconnected world. And that's a good thing. I think that we look at the kind of innovation and speed that our organizations are trying to accomplish, or hopefully successfully accomplishing. It's pretty exciting. The challenge around this is oftentimes we as security teams are working with perhaps the wrong ingredients, or ingredients that we haven't changed in a long time. And a simple example of that is one of the foundational network security components, of course, is a firewall. And if we think about what a firewall rule looks like, it's very simple. It says packets from this IP address are allowed to go to that IP address. And that isn't meaningful to anybody. There's no indication in that of why that rule exists. Why should packets be able to go from this IP address to that IP address? Under what conditions? Under what conditions should those packets be able to flow? What we really need is a way to align our security approach with what the business and compliance teams really want, which is a shift to something that's identity-centric, a way that we can look at things and talk about access and security from a user perspective, not from a data or a network perspective. Last bit of bad news is that as fantastic as TCP/IP is, and we built incredible things on top of this in the last 40 or 43 years, it really doesn't provide us with a strong foundation for security. Security was simply out of scope for that when it was created. And if we think about it, it operates under this model of connect first and authenticate second. What that means is our computer systems that are connected to, let's say, a corporate network or increasingly to the internet are visible to any device that's on that network. Any device on the planet can probe and scan and see what resources our services, see what services our servers are offering, and begin to take advantage of that. And we see this in attacks ranging from DDoS attacks to attackers that are able to exploit misconfigurations, default credentials, or known weak points. Now, the brilliance of what STP provides is that it flipped this on its head. And I certainly can't take any credit for this, but I still think it's amazing, is to say, let's take a model, let's adopt a model where users have to authenticate first, and then and only then can they connect to our resources and consume resources on our server and try to connect to them and use and perform their jobs. And what this means is, all of a sudden we have a much more secure foundation with which to innovate and interconnect and develop new types of technologies and business processes around this. It's pretty exciting. It's a pretty interesting new ingredient. So let's take a look at this in a little bit more detail. We have in the diagram a very simple network, a set of users connected to a corporate network and some resources in the cloud as well. The first thing to notice about SDP is that it's user-centric. Each user, as they connect to the network, gets an individualized perimeter that's created for them. That perimeter is based on the user's context and dynamically adjusts to changes in the environment. So as the user perhaps changes from device to device, or goes from the office network to their home office location or to an airport, the system can detect that, still provide them with an appropriate level of access, but do so in a way that's adjusted based on the context. The system is also dynamic on the server side. As new server instances are created or destroyed, especially in the cloud environment, the system will detect that, look at the attributes of that service, and then apply a policy that indicates and adjusts user access to those services. And that's the last, and from my perspective, one of the most interesting parts of this is that now we're not looking at firewall rules that perhaps aren't very meaningful. We're looking at consistent and meaningful policies. These policies are consistent because they apply universally for these users, for these identities, across on-premises and cloud-based environments. And they're meaningful. So now we have a policy that is going to make sense to people in the business, to the compliance team, and by the way, make sense to us on the security and on the IT team as well. So for example, we can have a policy that states Joe, who's in marketing, is allowed to access the marketing portal on this server over here through his web browser, but he doesn't get any other access to that. Sally, who's on IT, is allowed to RDP into that same server in order to apply operating system patches. And Sam, who's on the security team, can SSH into that server to download some logs, for example. Different users, different types of access to the same server in a way that adjusts according to who they are and how they're accessing it. So let's take a look at a real-world organization and how they're benefiting from this. Excuse me. Let's take a look at the SDP architecture. There are three main components in that. The SDP controller, a set of gateways that sit in line in the network in front of protected applications, and a piece of software that runs on the user's device. The controller is a central authentication point and policy store, and is typically connected to an organization's IAM and PKI infrastructure. When the user connects to the network, they will authenticate to the controller. The controller will perform an initial set of policy evaluations to determine the set of resources that the user, at this point in time, is permitted to access. When the user wants to do their job by opening up a web browser or running a client application, the user's device behind the scenes will establish a secure and encrypted tunnel across the network to the gateway, and the gateway will then perform a second level, a real-time set of policy evaluations to determine under what conditions the user should be allowed to access the resources. In some cases, the user will be allowed through. In some cases, they'll be blocked. In other cases, the user might be prompted, for example, for step-up authentication based on where they are. What's nice about this is it allows us to accomplish a couple things. First is because the network traffic is encrypted from the user's device to the gateway, we obtain the same level of security and integrity regardless of where the user is. So we can take these services and expose them to our users or our customers or our partners who might be across the planet communicating over an unsecured network. Second piece is that the gateway is dynamic. Not only does it adjust user access based on when the users move around, but it'll detect new instances in the cloud, look at their attributes, and allow or disallow user access accordingly. So now let's take a look at a real-world enterprise. This is a customer of ours that work in the financial services space, and they do a lot of data analysis on highly sensitive data. So they're very, very highly regulated, and they have very strict compliance reporting requirements. About 2 years ago, they made a strategic decision to shift from traditional on-premises compute to the cloud, and they've done a terrific job at that and are reaping technology as well as economic benefits of it. But the problem with that is they operate at a very large scale, and they work in a very dynamic environment, and I'll share some figures with you. On a daily basis, they create approximately 30,000 instances in the cloud. 85% of those have a lifespan of 5 or fewer hours. So what that means is there's a tremendous amount of churn in their environment. Many of those instances need to be accessed by administrative or DevOps folks as they're testing and building out the next versions of their applications. Clearly, they need some sort of dynamic and policy-driven approach if they want to be able to operate at the scale and maintain the security and compliance that they're required to do so. And actually, that's exactly what they've been able to obtain. They have very fine-grained control of which users can access which resources. The policies will dynamically adjust based on metadata of the instances that are created in the cloud and on where the user is and what device they're using. And they found that this dramatically simplified their compliance efforts. Prior to putting this in place, compliance reporting took them approximately 2 calendar weeks of a considerable number of people every 6 months. With this solution in place, they've now been able to reduce that to just a few hours of automated reporting and organization. So it's a big win for them. And what they've done is not only reap the economic benefits of being able to scale up and scale down, but now they're able to take advantage of some of the advanced technologies around big data and storage management in the cloud that they weren't able to do in their on-premises environment. So I hope that I have introduced to you here this new ingredient, this software-defined perimeter, in a way that helps you understand how it simplifies and allows organizations to transform the way that they're approaching security and shift it from something that's identity-centric from network-centric to identity-centric. That with this SDP approach, you can have much more precise and much more effective network security in a way that's aligned with how the business teams and compliance teams are looking to solve these problems. Through automation, organizations can get the kind of dynamic and high-velocity environments that they really want and need, and it enables security teams to, in many cases for the first time, say yes to the business. Yes, we can do this. This is how we're going to do this. We're going to support you in this initiative without compromising our security or our compliance. And one of the huge benefits of this is now these network resources are no longer visible to unauthorized users. So we've very significantly reduced the attack surface. If we have an organization of 500 people or so and 1,000 IT resources on the network, all of a sudden, each individual doesn't see 1,000 resources on the network. They see the 5 or 10 or 20 that they need to do their job. And when an attacker obtains a foothold in our organization through a phishing link that someone inadvertently clicks on, that attacker has a very limited attack surface, a very limited view of resources on the network. And we can expand that to our customers and partners, and we can very safely and securely take these services, put them on, so they're visible and available on the internet, but only to authorized users. We're not exposing ourselves to attackers from across the planet. Now, of course, this is a new type of approach, a new security architecture. And this is actually one of my favorite parts of my job is to talk to security professionals and CISOs and security architects and explain how SDP can apply in their environment. And there's a lot of interest and there's a great thirst for best practices and guidance on how it can be applied properly in their environment. And this is why over the last year I've been heavily involved in the SDP working group, and I've kicked off and led this initiative to research and define how SDP can apply into infrastructure as a service environments. And you can see these 6 use cases here, and I'm very pleased to announce that as of today, we've gotten this new research published. I have a hard copy here. It's also available on the CSA website through the blog there. So I certainly welcome folks to take a look at that. I'm happy to talk about it and get feedback on that. And now that I have a great deal of free time, I'm continuing my involvement in the SDP working group. And I'm actually leading an initiative which we've just kicked off to create a version 2 of the SDP specification. We'd love to have volunteers and participants in that, so please let myself know. It would be great to have some additional energy and folks involved. So to wrap up, I hope that I've explained to you this new ingredient called the software-defined perimeter and touched a little bit on how it works, why it's so interesting, and how it can be included in your recipe, if you will. With it, we've certainly seen organizations, our customers, be successful with it and be able to, like the financial services organization I talked about, deliver something that is amazing to their business, helps them accelerate and innovate, and deliver benefits both from a security, compliance, and business perspective. We've announced this new SDP for IAS research that's available today, and would love to talk further. I'd be happy to meet you at the CryptZone booth, which is in the South Hall 407. We can show you, we can talk through the research. We can show you how an SDP architecture might work in your environment, and of course, give you a product demonstration. Thank you.